All right, so we're going to be talking about this. Now, we got to figure this out. We got to figure it out. We are going to be counting. We are going to be counting on the abacus. When we count on the abacus, we need to do 1, 2, 3, 4. All the beads that are here is touching the horizontal bar. This is the horizontal bar. This horizontal bar is what tracks our abacus, our beads. The horizontal bar is what tracks our beads. So we have 1, 2, 3, 4, and then 5. After 5, we have 6, 7, 8, 9. And then, if we know this is 9, this is 9, this is 9, this is 9, this is 9. So all of these are 9. But now, these are all 0. Hello, RS, welcome! Wow, I'm so excited. I'm not alone now anymore. How are you today, RS? I'm so happy you're here. Okay. Did you get your abacus? Yeah, how's the weather? I don't know where you are. How's the weather where you are? Is it okay? It's a little rainy here in California. I'm in Southern California, so it's a little rainy, but it's okay. It's going to be good. It's going to be good because I'm waiting for snow. Oh, I can't wait to go snowboarding. Do you go snowboard? I like snowboarding. Happy to see you. It's Sweden. It's cold, but it's also sunny. Ooh, right. If it's sunny, how's the snow? Like, I wonder, so in California, we would actually have to go to the mountains to go snowboarding. Okay, but before I forget, we got to continue to count. So, welcome, everybody, welcome. Hey, Desmond Flack. We're counting on the abacus. For those of you that don't know how to read the abacus, this is a counting tool. This is a math counting tool. Usually, they introduce it for the children, but I have been noticing that adults are finding it very interesting as well. So, that's right, Sweden. Okay, in the state where I live, the snow has, that's too bad. Well, yeah, see, like where I'm at, I have to go to the mountains, so it's going to be maybe like an hour to 2 hour drive to go to the mountains, and then even then, the snow is a little bit 6, 7. 6, 7. What a crazy, okay, sorry. So we're going to do 1, 2, 3, 4, and then we have 4. We have 5. All the top bead has a value of 5. So we have 5, 6, 7, 8, 9. RS, do you have any questions? Let me know if you have any questions. Like if you have any math questions you want to look over, or any like addition, subtraction, multiplication, or division for the abacus, let me know. It's a free-for-all. And if it pushes the whole class forward, we will push the whole class forward. But yeah, we were doing multiplication and division and like really quickly yesterday, and I'm like, okay, let's do it, because nobody else really commented. So if you have any questions, if you have anything about even the worksheets and stuff, let me know. Okay, I don't have any questions right now. Okay, so what we're going to do is we're going to count 1, 2, 3, 4. Because there's 4, anytime the beads are touching the horizontal bar, we're going to count this 4. Now we have 5. All the top bead has a value of 5 no matter what. So as we do 5, we have 6, 7, 8, and 9. This is what 9 looks like. Now, how do I know that this is 9? Well, 9 is because I have my dot indicator. This dot indicator is right here on the horizontal bar. This little black dot right here. That tells me that this is going to be my ones place. After my ones, hello, Cynthia. Hello, Desmond. Oh, there's 12 people, but I only see 3 people on my list. Welcome, everybody. Welcome. Let me know if you have any questions about the abacus. I am here to, the worst player 2024. Let's do 2024. So we do 20, 20, 24. There we go. There we go. All right. So what we're doing is we're counting on the abacus. We count 1, 2, 3, 4. This is 4, and it's touching the horizontal bar. Because it's touching the horizontal bar, we call that this is 5. The top bead will always be the value of 5. So we have 5, 6, 7, 8, 9. This is 9. How do I know? Because, hello, Prof. We have our indicator. This indicator tells me that this is the ones place. Notice I have another indicator here. It doesn't matter which one you choose. It just matters you choose one. So as long as you choose one, you'll be fine. I decided to choose this one because I have a bigger number. Like I can do 10,000, right? How do I do 10,000? Well, this is 10,000. So all I got to do is 10000. That is 10,000. What? Thank you for following. Thank you for joining. Thank you for liking my live. All right. So this is 10,000. But notice this is 1. This is also 1. It just all depends on the value. Hey, legs. Hey, noodle legs. Okay, so it all depends on the value. It all depends on the place value. So we have our ones, our tens, our hundreds, our thousands, and our 10,000. Yes, you are back. I am so happy you're here. So we're talking about place value. As we talk about place values, we have our ones, our tens, our hundreds, our thousands, and our 10,000s. So when we're looking at it, this is 1, and this is 2, 3, 4, and then 5. Because the top bead has a value of 5, we have 5, and then we can add 6. How do I know? 5 plus 1 is 6. And then 5, if you notice, 5 plus 2 is 7. 5 plus 3 is 8. And then 5 plus 4 is 9. But then what do we do with this? Well, this is 10. Just as we have our place value, our tens. So this is our ones, tens. This is 10, 20, 30, 40. After 40, this is 50. After 50 is 60, 70, 80, 90. And then we will do that. This is 96. Hello, Danny. I've been curious about this my whole... Really? Is it that easy? It was so easy, right? Simple to use, easy to understand. Yes, as long as we understand how to read the abacus, then we can start going into adding, subtraction, multiplication, division. But the biggest thing, and I think that's the one hurdle, is understanding how to read the abacus. And I've been trying to find more ways to show how easy it is. So yes, it is that easy. We have 100. So right now we have 96. Can you do some addition problems? I can, Noodles. I can. Let me just finish this one thought about how to count and make sure that we're all okay. So we have 196. And then if we did this is 296. And again, I can do this, 5,296. Now, why am I calling this 5,000? I'm calling this 5,000 because I use this dot indicator as my ones place. So I have my ones, my tens, my thousands, my 10,000s. I'm sorry, my ones, my tens, my hundreds, my thousands, and my 10,000. And you'll notice that the dot indicator separates everything. What does that mean? So just like the comma when we write, we have 1,734. We do that. So if we do 1,734, and that's it. Right? Easy. Okay. So we're okay. Okay, if anybody else has no other questions, I'm going to continue on, and we're going to do some adding. But funny, I actually started doing a little bit of simple adding, and if you haven't noticed, so like here, if you look, we have our 5. This is 7. 5 plus 2 is 7. And it's simple, right? When we do 8, we have 5 plus 3 is 8. In the book, we start going towards the end, and what we need to do is we need to focus on the add-in. When we focus on the add-in, we're only looking at the thing that we are adding. In mainstream math and RS, I'm not sure how it is in where you are, but in America, mainstream math, in the younger elementary school, they're very focused on the result. Whereas what we need to do is marry the process and divorce the result. I'm going to use that. Why? Because in Abacus, we talk about the process. We talk about the add-in. We always want to know what is the number we're trying to utilize, right? So we're trying to add the 1. Easy, right? Easy because why? We're only going to add 1 bead. So if this is 5, I'm going to put 5, and then this is 1. I'm only going to add the 1 bead. Remember, we're focusing on the result. We're focusing on the process, not the result, not the answer. So my answer is now 6. Okay. So the next question the next number we will focus on is 2. Again, we focus on the process. We focus on the add-in, not the result. Just like life. We focus on our journey. We want to enjoy the journey, but the destination or the goal is all the same. We all want to be happy. We all want to be, good, right? We all want to, I'm hoping we all want to be healthy. But now the problem, now that what it is it's the journey to get there. Are we all exercising? Are we walking? Are we, having a good family? Do we have people that we like, or, is there TikTok, and TikTok is the best thing. So what I'm saying is it's all about the journey. It's all about the process. It's all about the add-in. So we have 5, and then I'm going to add 2, and this is 7. So again, what I'm doing is I'm just adding 2 beads. And then after that, we do 3, and it just goes down the line. But then what happens when there's not enough beads? Okay, well, let's talk about it. Okay, so here's the question. We want to add 4. This one says add 0, which is fine, right? Because there's no more beads to add. That's fine, because we're going to add 0. When you add 0, there's nothing there. Now the question is I want to add another 0. When I want to add another 0, now I have a little bit of a problem. Why? Well, I don't have any more beads to add a 0. What do I do? Well, in school, I'm not sure if you guys are, I don't know how old everybody is, and I'm just going to assume that we all understand how to make a 5. I'm not sure if they taught this when you guys were in school. I know when I was in school, and I've been in school so long ago, we were taught to memorize. We were taught to memorize our doubles. We were taught to memorize, and then now they're starting to talk about doubles and +1. So that's another strategy, which is okay. But in Abacus, we don't focus on memorizing the doubles because doubles is a one-hit wonder. It's only one way. You can only add doubles. If you subtract doubles, it's always just going to be 0, so it doesn't matter. But in Abacus, what we do focus on is we focus on the add in itself. So we want to do the question 4 plus 4. Now the question is 4. If we don't have enough beads to add the 4, my thought was, I got to go back to my thought. So in school, we are teaching we're teaching children that 1 plus 4 is equal to 5, or 4 plus 1 is equal to 5. The other one is 2 plus 3 is equal to 5, and 3 plus 2 is equal to 5. These are all the ways that all the ways we're making 5. Now that's fantastic, but the problem is, it's not a problem. But what it is school stops right here. What's going to happen is that Abacus actually supercharges. Let me see if I can draw a lightning bolt. Lightning bolt, like supercharge. So what's going to happen is we're going to isolate the variable. Hey, Phoebe, welcome. We're going to isolate the variable. What does that mean? Well, what we're going to do is we're going to take this, and it looks very similar to algebra. I talk slow because I really want to get into theatrical, dramatic thing. Hey, Georgia! All right. So what's going to happen is if I do x plus 1 is equal to 5. This is very much like algebra. Thank you so much for the likes. Hey, Abel. Hello. We're talking about Abacus, but it's a little bit like algebra. But it's not algebra, I'm telling you. This is not algebra. All right. What we're going to do is we're going to isolate this variable. So we're going to isolate this variable, right? It looks very familiar, doesn't it? So we want to take this 1 and we put over there. When we do that, we're going to say x is equal to 5 minus 1. Then, who's the target audience for this? For what I'm talking about? Adults, parents, teachers, grandparents, and older people for right now. And if I can teach you how to use the abacus, you will teach your children if you have any children. Or you can teach your students if you have any young students. Or if you would like to bring in abacus to math intervention. So it's like an enrichment program. I hope that makes sense. Hey, Dougal. All right. So we have this. What's going to happen is let's replace it back, right? Let's put it back and we do 4 plus 1. So what are we trying to do? Well, what we're trying to do is we're trying to add the 4. When we add the 4, we don't have enough beads. We're going to supercharge this. We're going to supercharge this concept. We're going to dive deep. We're going to supercharge this concept. Thank you so much for liking the live. Yes, Runa. Welcome, welcome, welcome. Yes. Thank you, Dougal, for the question, but let me know if you have any others. This is not for everybody. I'm just letting you know. This is not end all. It depends if people are open to it. It's a different way of looking at things, but it's not new because Abacus has been around for a very long time. It's just different. Well, just like new math. New math is different, but new math is actually Abacus math if you really think about it. It's 8. It's 9 o'clock for me. Oh, sorry. Right, right. So what we're doing, but the thing is we want to know what the process is. So here it says plus the 5 minus 1. So all I got to do is plus the 5 and then take away the 1. And then my answer is 8. Yes, Savannah, that is exactly what it is. So what I just did was to show you, and it's like, okay, well, I already know doubles. It's like, well, okay, we're not talking about memorizing doubles. What we're talking about is memorizing the formula. This is a formula. So let's take it one step further, right? Let's take it another step further. Once we understand this, we can do the next problem, which is 2 plus 4. This is also easy, but understanding the fundamentals it's better. We need to understand the fundamentals. We need to memorize the fundamentals so then we can go into further and we can start scaling it. Because when the questions get bigger, then we're going back to be like, okay, let's start, doing all these strategies. Whereas in Abacus, we already know this. So if I add the 2 and we realize we're going to have a conversation with our Abacus, we're going to have a conversation with our number, with our question. Can I add the beads? No, I can't add the beads. What do I do? Well, we remember that we need to plus the 4 is equal to plus the 5 minus the 1. So I plus the 5 and I take away the 1. And now my answer is 6. Right? Does that make sense? Are we okay? Everybody put in 6 if that makes sense to you. Put in 6 into the comments if you understand that. So this is the formula. The formula is what we have. Right? Right? Thank you, William. Thank you, Yer. Yes. But see, the thing is, okay, you know what? That's really easy. I was like, yes, I understand that's easy, but it's the fundamentals that we're trying to figure out. Because why? When we get to bigger numbers, right? When we get to bigger numbers like, I don't know, 32 plus 41. Let's do that, right? So in school, we do 2 and then we do 3. But in Abacus, we do it as a whole. This is only, again, another 30. We do 2. Well, what do we do now? We do 41. The way we talk is the way we add. So we do 41. When I want to do 41, I know how to add the 4. When I'm doing this, what I want to do is I want to isolate the column. This column is adding the 4. I don't need to look at the whole thing. Oh, sorry, that's not 32 at all. That's like 3,000. 32. Sorry. So that's 32. So what I want to do is I want to add the 3 to this column. That's it. I am bringing it down to manageable chunks. So I want to add. We start off with the lower numbers to understand bigger numbers. Am I right? Yes! Yes, Runa! Exactly. Because a lot of people will be like, you know what? That's so easy. You make it really complicated. It's like, well hold on. Right? We need to learn how to use our muscles before we start running, right? We need to start learning how to crawl before we can start walking. We need to learn how to walk and then we can run. After we run, then it doesn't matter, right? So exactly, Runa, exactly. So what we're going to do is we're going to add the 4. When I add the 4, I know how to do it. I'm adding the 4 is plus the 5 minus the 1. So what I'm going to do is I'm going to plus the 5 and I take away the 1. Then I add my 1. After I add my 1, now I have my answer. And I look at it as I take a step back and I'll be like, okay, I've done the work. What's my answer? My answer is 73. Does that make sense? Are we okay? Are we tracking? Are we tracking like a horizontal bar? Because that's what a horizontal bar does. A horizontal bar tracks all my beads. So we have counting. So let's count it again. We have 1, 2, 3, 4. All the lower beads has a value of 4. So then we have 5. The top bead, no matter what, is a value of 5. Thank you, Tone. Value of 5. After 5, we have 6, 7, 8, 9. After 9, we have 10. But notice, this looks the same, doesn't it? 1 and 1. 1 and 1. What you gonna do? Well, this is where place value comes into play. Just as we do the 1s, the 10s, the 100s, and 1000s, right? If I do a 1 over here, Well, how do I make this a 10? I make it a 10 with adding a 0. So when we look at our columns, when we look at our digits, when we look at our place values, it's our ones, our tens, our hundreds, our thousands, and our 10,000. Does that make sense? Are we okay? Yeah? Hey, Tyler. Okay, and so we have in the question ton 15. So to do 15, 1 and a 5. How do I know? Well, the top bead is a value of 5. The bottom bead has a value of 1. So it'll be 1, 2, 3, 4. No, not 1, 2, 3, 4. 10, 20, 30, 40. Because now we're talking about our tens place. You can choose any of these indicators. These indicators helps me figure out where the 1 is. It helps me figure out where the home is. No matter where your home is, as long as you call it a home, right? So you can have multiple homes, but you still only have one home. So that's why you choose the one indicator. You could choose this one, not a problem. This could be your vacation home. Well, I would like to have a vacation home. But it doesn't matter. You could go here, it doesn't matter. If I had a bigger abacus, notice I have other places that I can go to call home. Make sense? So it doesn't matter. This is a 13-column abacus. This is a 7-column abacus. The only reason why I would start in the middle is so then I have a lot more digits in the front and a lot of digits in the back. That's it. That's the only reason. It's all about perspective. If I want to have a lot of money, then I would start here. If I want even more money, I want to start here. Right? Hey, space-time, welcome, welcome, welcome. All right. Does that make sense, Runa? Okay. And RS, I don't know if RS is still here. Okay. So when we're going to count again. We do 1, 2, 3, 4. This is 4. This is 4, and then this is 5. After 5, because all the top bead is a value 5. Oh, and that's the other thing. The top bead is what we're talking about. The top bead, not the color. It's easy to talk about the color because we're, on video and stuff. However, it does. Thank you so much. Thank you for loving my work. I do appreciate it. I do appreciate it. And let me know if you have any more questions. But we're going to continue on with adding, subtraction, multiplication, division. It just depends on how far we can go with division. Okay, so notice this is the same color, right? But it's all about the positioning, and it's all about attention to detail. Why? Because I need to know that the top bead is touching this horizontal bar. Does that make sense? So as the top bead touches the horizontal bar, just like this is what we call 5. And then we do 6. So this is 6. Make sense? What if adding requires regrouping? Oh, it's Sasha, that's the best thing. Actually, we don't call it regrouping in Abacus. We call it adding a 10. It's so easy. I'm telling you. I'm telling you. It's so easy because we have formulas that already incorporates grouping and regrouping. Let me show you. I'm so excited. Oh, this one is 73. So I'm going to write down my 73. Okay, so regrouping. We're going to talk about regrouping. Before I talk about regrouping, we need to understand a fundamental concept. And one of the concepts is, how do we make a 10? Right? We know how to make a 10. 9 plus 1 is equal to 10. Right? 8 plus 2 is equal to 10. We all understand this. So if we all understand, now what we're going to do is we're going to supercharge. This is, that's what I was trying to do here. I was trying to draw. I got to practice my drawing. That's what I got to do. Okay, so what we're going to do is we're going to supercharge our concept. What does that mean? What we're going to do is we're going to isolate our numbers that we need to use. We can isolate these numbers. What that means is if I want to use this 9, I just need to move this 1 over here. Does that make sense? Are we okay, Sasha? Does that? So this is a introduction to algebra, but not algebra. Just so you know, I'm not doing algebra, I'm doing abacus. It just happens to be algebraic. This is algebraic formulas, and that's one of the Common Cores I was reading. I was like, what? We already do that. So it was funny. It was really funny, William. My son would go into algebra class. He goes, I don't know algebra, but I know it. I don't know why. And it's because I learned this. I actually learned all of this in primary school, but it's been a long time. Yeah. Funny, I never learned any of this. I learned this because I learned abacus at 30. So what we're going to do is we're going to add the 9. To add the 9, we're going to plus the 10 minus the 1. What does that mean? So if I have my question, 9, right? I want to add the 9. My question is 9. I'm going to do 9 plus 9. But know that we do not memorize our doubles. What we memorize is the formula. We memorize the concept. This 9 is the same thing as this 9. So what we're going to do is, because we isolated the variable, we're going to substitute this into there. So what does that mean? When I want to add the 9, and this is the regrouping that we're talking about, this is the grouping that we're talking about, all this means that I'm going to go to the 10. When I go to the 10, just means I'm going to go to the next column over and I add the 10. That's it. That's it. So I go to the next column and I add the 10, so that's 1. And then I have to take away the 1. So my answer is 18. Does that make sense? So this concept is what we're teaching. We're teaching the kids this. But then Abacus supercharges it and makes it into this. We can do it again for the 8, right? We could do it again for the 8. Let me go back. So we could do it again for the 8. 8 is equal to plus the 10 minus 2. Really? That's it? Yeah, that's it. That's all we're doing. So let's start over. Let's do 9 again, right? Let's do 9. Now, these are very simple addition, but learn how to crawl before you walk. Learn how to walk before you run, right? This is what we're doing. We're building on top of each other. Hang with me. So we have 9 plus 8, right? 9 plus 8. So here, I want to add the 8. Again, our add-in is to plus the 8. All we have to do is plus the 10 minus the 2. That's it. That's it. Plus the 10, take away the 2. And my answer is 17. I kind of remember it now. Yeah, great. Not a problem. Not a problem. Right? And then it's 17. But see, the thing is if you know this, the reason you actually remembered it, and it goes into your long-term memory, and then trying to retrieve it to your working memory is a different story. But if you know this, and it's probably really ingrained in you. Like my kids, they know Abacus, and so it's ingrained in them. Ask them what it means, they have no clue. But the idea is it's ingrained, so you know it. Now the question is can you teach it? But when you teach, it becomes as part of working memory. So it's been part of my working memory, right? Because I'm talking about it. But if you know it, then yeah, then it makes sense. Okay, cool. So let's talk about it again. We have 17. Let's do the reverse. We know this. Plus the 8 is equal to plus the 10 minus the 2. I'm sorry, plus the 10 minus 2. Because we know how to add, there is the inverse. The inverse is minus 8 is equal to minus the 10 plus the 2. Are we okay with that? So let's do the inverse. I'm going to take away 2. I'm going to take away 8 from 17. So if I do 17 and I take away 8, right? What is it? So what did we just do? We just learned how to isolate the variable. As we isolate the variable, we have this skill. Now we build and we do the next step, which is now minus. So do you see there's a similarity? We add the 8, we can take away the 8. So again, thank you so much for sharing the live. So again, this is building and diving deep. What was it called? Deep dive into understanding how to add and subtract. Once we understand all of that, everything's gold. Everything will scale. It doesn't matter. I don't need to do like more addition or subtraction strategies because I know the fundamentals. It can get a little bit convoluted. You've got to keep track, but just like everything in life, right? You've got to keep track of what you've got. Okay, so what we're going to do is we're going to take away the 8. So 17 take away 8. I'm going to take away the 8. What do? I minus the 10. All I'm doing here is going to the next column. So if I am here, right, I want to take away the 8 here. It doesn't matter if I'm in the hundreds, the thousands, the 10,000, it doesn't matter. It's this specific column, and I need to go to the tens to take away. That's it. Does that make sense? So I just need to go to the next column over. That's it. So I take away the 10, and I plus the 2. And my answer is 9. Yeah, right? So, anybody have any questions? But thank you for the regrouping. Thank you for the regrouping. It's been good. Yeah, it's called grouping, regrouping, old math. It's called borrowing and carrying over. When I learned it when I was a kid, it was called carryover, but new math is called grouping and regrouping. Okay, but that's a little bit. So we did a little bit of how to make a 5. Now we did a little bit about how to make a 10. And that's it. And when we know how to do all of that, it becomes more, I need to write the number. When it comes down to it, then we start talking about how does it all fit into each other. Now, there's things what we call two-step equations. Two-step equations just means that we don't have enough beads to add this to, we got to break it up. So what does that mean? Well, let's do, I think, 16. So we'll do 16. We'll do 16 take away 8. Can we do that? Yeah. So 16 minus 8. This is our two-step equation. Thank you so much for sharing my life. Joralise. 16. So we do 1, we do 6. We're going to take away the 8. We know how to take away the 8, right? We know how to take away the 8, but the problem is this 2 right here. Why? Because once we take away the 10, we need to add the 2. There's not enough beads to add the 2. What do? Well, we remember our how to make a 5. When we isolate this, I want to isolate my 2. It is 2 is equal to plus the 5 minus 3. Okay, this is what we have to memorize. And now what we're doing is we're building a scarf. Because you have the fundamentals, you have your yarn, right? You have your fundamentals. And depending on how you make your knots, you can either make a sweater, you can make a hat, you can make a scarf, you can make mitts, you can make, socks. So now, because I know I need to add the 2, I need to plus the 5 minus the 3. That's not right. Oh, I need to take away. I need to plus. Wait a minute, plus the 2. Oh, no, this is not it. Because we did this, we plus the 2. No, I don't need to do this, because I already have it. Sorry. Because look, if I take away the 10, I need to plus the 2. Do I have enough beads to add the 2? I'm the other way. Do I have enough beads to add the 2? Yes. So those are 2 questions. These are questions you need to ask. Is there enough to add the 2? Sorry, my fault. So yes, there is enough to add the 2. So my answer is 8. I was trying to do, I guess it was 14. I guess it would be 14. 14, yeah, it would be 14 minus 8. So let's try that, right? Take away the 10. So I take away the 10. This is what it is. Plus the 2. Plus the 2. I don't have enough beads to plus the 2, but I can use the 5. This is what I meant. So this is okay, but now we're over here. Okay. I'm hoping that everybody's okay. Hey, Luna, how's it going? All right. So what do? We already take away the 10, and we need to plus the 2. Cannot plus the 2. There's not enough beads to plus the 2. So what do? I have to plus the 5 and take away the 3. So my answer is 6. That's what it is. I was trying to do two-step equation. But this is why it's a two-step equation. Because we have our 10, and then we have to also use the 5. Does that make sense? Whew, I think I lost some people. No worries. It's okay. Because the understanding is the fundamental. When we understand our adding and subtracting of 5 and our adding and subtracting of the 10, then it's easy to see. Okay. So, hey, Gabby, just joined. Okay. Because Abby just joined, let's just do a little review. Let's do a little review and start counting. We do 1, 2, 3, 4. If anybody has any questions, let me know. We can continue on, but let me know if you have any questions about adding, subtraction, multiplication, and division on the abacus. So this is 4, because anytime it touches the horizontal bar, these are being counted. None of these beads are counted. Hi, Arksy. So none of these beads are being counted. That's why this is only 4. When we have the top bead, this is a value of 5. So we have 5, and then we have 6. We have 5, 6. All the top bead has a value of 5. Because this is 5, and then we add 1, this is 6. When we add 2, 5 plus 2 is 7. And then 5 plus 3 is 8. And then when we squish them all together like this is 9. Because this is 9, we know that after 9 will be 10. We've seen 10. It looks like this. Now, what do you mean? Well, if you look, this is 1. This is 10. What's the difference? The difference is the place value. The place value of the abacus. So just like the place value, as we write, we have place values on the abacus. So this is the ones, this is the tens, this is the hundreds, the thousands, and the 10,000. So if I did 10, 100, 1,000, 1000, and then 10,000, 10, 1, 0, 0, 0, 0. Does that make sense? Selfish Sharon. Thank you. Thank you for joining. Luna, do you have any questions? Runa, do you have any questions? And William. Those are the only people that I see. But what we're going to do is we're going to count again, just in case Jibby doesn't know or Emily doesn't know. Thank you so much for liking my live, Emily. Okay, so just to review, let's count, because the idea is to understand how to read the abacus. When you understand how to read the abacus, then we can start going into adding, subtraction, multiplication, division. Thank you, Jibby, for liking my live. Oh, I might have my Sydney. Thank you. So what we're going to do is we're going to review how to read the abacus. So we do 1, 2, 3, 4. Does that make sense? Oh, it all makes sense, right? Simple to use, easy to understand. William, let me know if you have any questions. Let me know if you have any math questions that we can do. And we'll see how difficult it gets. Because it does depend on blocks, right? Building blocks that we need to acquire. This is 4. Anytime that the beads are touching the horizontal bar, Sydney, is counted. So this, the top bead, is a value of 5. This is always going to be 5. So this is 5, this is 5, that's 5, this is 5, this is 5. But if you notice, I was really quick about it. Now, the other thing is to understand that there's place values, right? The place values also comes into a factor, where we are located in the columns, where we're located in the place value. So if this is my ones, I have 5. This would be 50. This 500 would be 500. This would be 5,000, 5000, and then 6. I'm sorry, this would be 50,000, 50000. Do a subtraction problem. How would it work? Subtraction problem. Let's do it. Well, the easiest subtraction problem we would do would be something if we already have our numbers. So we have 9 and we just take away 2. So 9, and all we got to do is take away the 2. The biggest thing is to understand that there's formulas involved. So after we learn how to read the abacus, right, we know how to subtract. So those tiny dots on the white thing are supposed to be commas. Actually, no. These white little things are dot indicators. They help us indicate which one will be our ones place. At this specific moment, I chose this one to be my ones place, and then this can be my comma separator. So it joins my groups together. If I choose to, I could say that this is my ones place. So instead of being 6 here, I could be 6 over here. So the dot indicator, the little black dot, just helps me label home, if that makes sense. Now, on the small abacus, it's okay, right? It doesn't matter. But on a bigger abacus, on a 13-column abacus, now it matters. Because if I chose this to be my ones and my answer is over here, then this is going to be like 11,000, right? So the question is if I chose this, then this will be my ones. So it all depends about perspective of life. It just matters of what is it that you need. Do you need a large number, right? A large number, so I could start from here and I have 13 columns to have my number, or do I have to have a really small number with a bunch of decimals? So it all depends on where you want, what you're trying to accomplish, what you think you're trying to accomplish. So after the ones will always be the tenths. The decimal always sits between the two columns. So here is my decimal, right? My ones, my tenths, my hundreds, my thousands. So, but it's nice to have the groups, right? So if I started here as my ones, I know this is thousand. I know this is million, this is billion, and then this is trillion. So it is about commas, but it also depends on where your ones will be. So the simple adding and subtracting. Simple adding and subtracting. Why is it simple? Because we have enough beads to subtract. The next thing we're going to do is we're going to try to understand, well, what if we don't have enough beads? So the first thing we can do is we can do 8. When we do 8, we take away 4. Let me do that again. If I do 8, if I have 8, I minus the 4. To do a subtraction problem, this is what I'm going to do. I have 8, but I want to take away 4. There's not enough beats to take away the 4. So I have to know a formula. What does that mean? We are teaching children how to add 5, how to make a 5. Why is 5 a critical thing? Because 5 is a block that we can use. We can supercharge this concept. What that means is I'm going to isolate this variable. I'm going to make it a minus 4. To make it a minus 4 is minus the 4 is equal to minus the 5 plus the 1. So what's going to happen is all I got to do is minus the 5 and then I add the 1. Then my answer becomes 4. But again, this is an abacus formula that we need to memorize. That's what we need to memorize. We need to memorize how to subtract a 4. Not do you know your doubles, right? We don't need to go reverse here to get to 8. All I need to do is how do I subtract the 4? I know how to add the 4, right? And now I'm building this concept. If I can add the 4, I can take away the 4. This is not a separate concept. It's the same concept, just building on top of each other. So now we're going, hey, mozzarella. That's a funny name. So this is about building the knowledge that we have. This is not about creating new variations of how to do subtraction and addition, if that makes sense. We can do some more. So the next one is, so this one was the example that I gave out earlier. We want to add the 9, but we want to add the 8, right? We have the 9, and then we want to add 8. Our 8 is now supercharged. We're going to supercharge our 8. We have our 8. 8 plus 2 is equal to 10. Because 8 plus 2, can you multiply and divide? Yes, you can multiply and divide also. We can do that right now. After, let me finish this concept, and we'll go into multiplication. Division's a little bit more. Division's a little bit more. There's a little bit more to it, but it can be done. Okay, so here's my concept. So we when we do the adding of the 8, right? Again, we know how to add 10. We know how to plus the 10. But in order to do this, we're going to supercharge it, and we're going to isolate our variable. We're going to isolate our 8. So the question is, so what's going to happen is our formula is plus the 10 minus the 2. So I'm going to plus the 10, and I take away the 2. And so my answer is 17. And then this was the opposite. If I want to minus 8, I know how to add 8, and all I got to do is build and reverse my operators to minus the 8. And it's exactly the same except for the operation, right? If I'm adding an 8 or I'm taking away the 8. If I'm taking away the 8, then I take away the 10. So that means I just go to the next column and I take away 10. And then here, it says plus 2. So all I have to do is plus the 2. So then my answer is 9. And that's what that is. All right. So some multiplication. Let's do, it will be good. Let's do some multiplication. Oh, so one thing about multiplication is in Abacus, we don't need to know, we need to memorize our multiplication fact. That's the one thing you need to do. You need to know, and you need to make sure you understand and memorize your multiplication fact. You could do it on the Abacus, but it's a little tedious. Why? Because it'd be like cumulative addition. That's what it would be, right? So if I needed to do 9 plus 9 plus 9 plus 9. So you have to keep track of that, right? You would have to keep track of that. But the next thing we need to do is after we understand our addition and subtraction formulas, we would have to memorize our math facts. So the first thing we're going to do is we're going to have our question. 84 times that by 8. What we need to do here is understand where are we going to put this answer on our abacus. Why? Because we just need a ballpark idea, right? We don't want to put it here. We don't want to put it here where the ones is, because that's how we don't put it here. You could, but it'd just be backwards. It'd be kind of confusing. So what we need to do is we need to understand that we're going to add our digits. 1, 2, 3. We're going to add our digits, so we have 3 digits. So I know my answer is going to be somewhere in the hundreds column. That's the idea. Get a ballpark idea where we're going to be located. But I'm going to put my finger here. Then the next thing we need to do is 8 times 4. I'm sorry, 8 times 8. 8 times 8 is 64. So I have my 6 and I have my 4. I don't need to say 80 times 8. I don't need to say this. Why? Because the abacus does it for me. See how it says 640? I don't need to do it because in new math we write it out. But in abacus we see it. So we don't need to do this part. We just need to know the basic. We just need to know the fundamental. We just need to know the manageable chunks. We're done with that. The next one is 8 times 4. 8 times 4 is 32. 32. So I add my 3, I add my 2. How do you add 3? Do you remember how to add 3? Well, my question is plus the 3. My formula that I have to memorize is plus 3 is equal to plus the 5 minus 2. I'm sorry, that's a minus. Minus 2. This is a formula that we've had to memorize, right? We've been working with this. So plus the 3 is equal to plus the 5, take away the 2. And then we need to add this 2. So I go over here and I add the 2. So my answer is 672. Does that make sense, Emily? Anybody else have questions? William, is that okay? Make sense? Yeah? Yes, right? Makes sense. Yeah. And so the difference is in new math, we write it out. Good. Fantastic. So cool. Yes. It's simple to use, but a lot of it, if you really think about it, a lot of it is just the abacus helps you track. You're doing this in your head. So, and that's the difference. I think that's the difference. Sydney, you're okay? Yeah, I don't know if RS left. It's okay. And then Runa and Luna. Anybody else out there? Let me know if you have any questions. Let me know if you have any questions. We can continue on. We can do another multiplication question. Yeah? Okay. Yeah, because I noticed, you know, don't underestimate addition, right? But I know a lot of the questions go into it. Yeah, Sydney, I'm okay. Just processing this. It's neat and cool. Yeah. Do you have any tips if I struggle with times table? You know, that's the one thing that I was trying to figure out. You could get into like understanding how to make it into arrays. So you know how they do like these little boxes and try to understand that? I never did that when I was a kid because we never did this. So here we go, 1, 2, 3, right? And then we have 4. And then you count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You could do that if you're very visual. You could try doing this. You could try understanding, well, okay, in the abacus world, let's do 4, for example. In the abacus world, what I did with my kids is I made them do cumulative addition. And they got tired of it, and then but they're starting to see what they did. So if I did 4, and I would need to add another 4, I'm going to change my color. I need to add another 4. So 2 times 4 is, if I plus the 5 minus the 1, is 8, right? And then if I did it again, add another 4, this one is plus the 4 is equal to plus the 10 minus the 6. So I plus the 10 minus the 6. So that's already 3 that I did, right? So 3 times 4 is 12. So you could try doing that and do it enough times that you see the numbers. And you know what, when my kids didn't know their multiplication, I said, you know what, then work it out on the abacus. Because I think what it is we don't pay attention to what we're doing here. So when we're going to add another 4, what does that mean? I want to add another 4. So 4 plus 4, add another 4 here. How do I add another 4? Plus the 4 is plus the 5 minus the 1. And it could be that you don't see these numbers working. So it could be that scene. I don't know if that helps you. But I noticed that with my kids doing it this way, it helped them a lot, and they got tired of it because they've seen it so many times. And if you see it enough times, then it'll make more sense. I don't know if that helps. I hope that's okay. You could try doing it through the abacus way and just, now I need to add another 4. What do? Plus the 10 minus the 6. And that gives me 20, but that means I'm at here, which is, I'm just using this as a tracker. I'm not using this to help me with anything. So if I'm doing 4 times 5 is equal to 20. So that's what I would do. And that's what I did with my kids. All 3 boys, they had problems with their multiplication. I said, you know what, work it out on the abacus. Because after you know your adding and subtraction, then you should be able to do your because what is multiplication? Multiplication is just fast addition. It's just how do you get there? So I think that's the thing, is the problem is maybe your addition, maybe the addition skill is a little bit lacking, that it's difficult to see, right? So we are taught to memorize multiplication, but sometimes we're not taught like the fundamentals of multiplication. And I think abacus helps with that part, where if you need to know, 6 times table, right? Well, 6 times 1 is 6. 6 times 2 is 12, plus the 1, add another 6. Add another 6 to here, which is plus the 10 minus the 4. Minus 4 is minus the 5 plus the 1, right? Plus the 6 times 3, add another 6. I have 12, add another 6. So I add another 6, that's 18. And I do add another 6. How do I add 6 here? Plus the 10 minus the 4. Cannot minus the 4. Minus the 5 plus the 1. So I don't know if that helps, but that's what I would do. And then if you need another add another 6, because then we get the 5. So plus 6 is plus the 10 minus the 4. Okay, so let's go back. And then abacus, because we rely heavily on multiplication fact, maybe start doing it through abacus. Just have to practice. Yeah, you just have to continue to practice. And I think that's what it is just not understanding to see how this. An old 70s, hey Krista, an old 70 multiplication keyboard is what made it click in my older brother, me, back in the 90s. Oh, that's interesting. So you're talking about like this one where we had the multiplication table? Or no? I don't know what the multiplication keyboard is. Ooh, I will have to look that up. First multiplier. That's interesting. All right, I'll take a look at that. All right. So what are we doing? We're doing more multiplication. So the question is 53 times that by 4. The first thing we're going to do is we are going to... It was a multiplication table that worked with buttons. Oh, interesting. Oh, yeah, like the popper. Let's see if I have a popper. I don't know if I can find it. I'm trying to find my popper. Oh, here it is. No? Yeah, here it is. So is it something like this where they're using as a popper? And so they do like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, exactly like the power, but just different tactile experience. Yeah, I could see that. I actually never thought of this. I had it just because I had it, but then it was okay. I don't know how to use this as a I guess, what is it? If you did... Sorry, now I'm just playing with it. So if you did 2, and then 1, 2, 3, 4, I guess it's because it talks about like area, because 2 times 4, 1, 2, 3, 4, that means you have 8. 1, 2, 3, 4, 5, 6, 7, 8. I could see that. Yeah, so if I did 3, 1, 2, 3, times that by 4, 1, 2, 3, 4, then I have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. I never learned it this way. I was just taught to memorize. Yeah. So, all right. That will be part of my little thing. Okay. So the first thing we're going to do here is we're going to we are going to, thank you so much for sharing the live. We are going to count our digits. That's what we're going to do. 1, 2, 3. So we know our answer is going to be somewhere in the third column. 1, 2, 3. The next thing we're going to do is we're going to go outside first. We're going to do left first. We always go left to right. So 4 times 5 is equal to 20. So we add our 2, we add our 0. And then 4 times 3 is 12. Thank you for the share, William. 4 times 3 is equal to 12. We add our 1, we add our 2. So our answer is 212. Is that right? 212. Yeah, that's right. Yep. Is that okay? Everybody's tracking? Maybe I should have like a little acronym. HB. Tell me if you're HB, like a horizontal bar. HB. Because you're tracking. Hey, Cha, welcome back. Okay, so anybody have a question? Anybody have questions? We can continue on with multiplication. Let's see. What are we doing? Can we try one more as a test? You want to try to read it, or you want to try to do a multiplication question? Because we could do that too. Let's see. We did this one. We did this one. You know, this one would be good. We could do this one. Let's do this one. 58 times that by 6. So what is the first thing we need to do? Okay, so yeah, let's do that. What is the first thing we need to do? You tell me what we're doing. Yes, Sasha, tell me, what do we do now? Oh, I don't know if you can hear my dog barking at something. Hey, Joya Bean and Lolita. I think it was Lolita. Okay, what are we doing? We're doing this question right here. What are we trying to do? Maybe I should move this down. What do we do first? Do we know? Do we remember? What do we do here? We count. Yes, thank you. We count our numbers. We count our digits. 1, 2, 3. So where are we going to start? If we're at 3 digits, where do we start? Oh, that's not right. If we start here, the third digits, what place value do we start? If I did this, right? What place value do we start? We start at the hundreds. Thank you, William. We start at the hundreds. So what do we do now? Thank you, Sasha. What do we do now? There should be an Abacus cartoon that walks through your for the littles. Yeah, I had one that was a little brain. I wasn't thinking about bringing it in, but that's a good idea. You know what, I will. It was like a little brain with some stuff. Yes, Sasha, that's what it is. 5 times 6. Like a baby holding signs, introducing sign language. Yeah, I was going to do like a little brain because I was thinking it was going to be like brain gymnastics. So 6 times 5 is... It's been a while. I actually had to reorganize my Canva, and I found my old stuff, and I'm like, I got to bring that back. So, yes, go to funds. Thank you. So 30. So I had 3, and I had 0. There's nothing to do with 0, right? So what's the next thing I have to do? What's the next thing I have to do? It's different to watch somebody as opposed to tell me what I'm supposed to do. I try to provide prompt questions. But these are also questions you would be asking your students, right? What do you do next? Thank you, William. 8 times 6. So 8 times 6 is... Thank you, William. 48. So I had 4. Thank you, Sasha. And I had 8. And that's it. That's my answer. What is my answer? Oh, sorry. Yes, you're right. Yes. It is 348. The answer is 348. Yeah. Sometimes my fingers move the abacus, and so you have to be careful with the abacus because it's easy to move. Yeah. There was one time where my brother, so we have a learning center out in Monterey Park, and if he sees you not holding your abacus and it's a big long question, he'll come by and he'll just shake it up, and then you have to start over again. I mean, it's a little mean, but it's to it's to make a point that you need to hold your abacus. So that's it. That's pretty good. Yeah. Thank you. That was a good one. Should we do another one? So these ones, what we call is simple because we have enough beads. Okay, I need to go. Thank you for tonight. Oh, yeah. Oh, Sasha, go to sleep. That's crazy. Thank you for joining me. Thank you so much for joining me. And thank you for mathing in the midnight math. Thank you for midnight math. I appreciate that. Yeah. Have a good night and sleep well. Anybody have any more questions? Let's see. Anybody have any questions? We can continue on. I know what to teach my students. I know what to teach my students already. Thanks. Oh, fantastic. I hope it's going to be abacus based. How do we divide bigger numbers? It's the same thing, but again, you still need to memorize your multiplication fact, right? But the way we do division is we use our multiplication fact, which is interesting. We don't say how many times does whatever divided by into this. What we do is we do a comparison. So let's do some dividing. When you say bigger numbers, I'm going to assume it's going to be like this one. 2 divided by 846. Is that okay? Do we want to do this? Hey, Natalie. Is that all right? Or do you want something bigger? Okay, good. So what's going to happen, the first thing we need to do is understand where our dividends are and our divisors. Why? Because we're going to start having more of a conversation. And I have to find my little... there it is. We're going to have a conversation with our abacus. We're going to have a conversation with our question. So we need to realize that this is our dividend and this is our divisor. And I'm going to use this one because this one doesn't have enough beads. What will happen is we're going to figure out again where our place value is. Where are we going to put our answer? Now in multiplication, we added the digits. In division, we subtract the digits, right? Just like how multiplication is fast addition, division is fast subtraction. So we have to make sure that those, keep hand in hand. So we have 3 digits is our dividend. Take away 1 digit is our divisor. Now what's going to happen is there's a chart that I like to build all the time because we need to do comparison. What are we comparing? We're going to compare our 1 digit from our dividend and 1 digit from our divisor. It's always going to be a 1-to-1, no matter what. It will always be a 1-to-1. And then knowing what number is bigger or less will tell me what the next steps are. So this is the conversation we're having. We have to compare our 1 digit from each column. So our divisor is 2 and our dividend is 4. So my question is, who is bigger? Which one is bigger? The 4 is bigger, correct. Our dividend is bigger. Because our dividend is bigger, now we know what to do. We're only going to, sorry, I missed something. I missed a step. We got to put in our answer. So we're going to be here. This is where our answer is. So our answer is going to be here on the 2, right? Because this is 2. So 1, 2. And then after this, the next column over, I'm going to put my dividend. 4, 8, and then 6. Now we compare 4. So because 4 is bigger, the rule is skip 1, subtract 1, or eat 1. That's what we need to do. So we need to skip this column. I'm going over here. And we're only going to look at one digit, only one column. The question is now, 2 times what is equal to 4 or less? 2 times 2 is equal to 4. So that means I'm going to add 2 to this column. And then I take away 4 on my dividend. Take away 4. So now I have to reassess. My dividend is now changed. I have to reassess. To reassess, I look at my one digit, my one column. 7, no, that's wrong, 8. 8 or 2 is my divisor. 8 is bigger or 2 is bigger. We know that. Thank you so much for sharing my live, Kobe. We know, thank you, William. We know 8 is bigger. So if 8 is bigger, we go back to our rule. We go back, thank you so much for sharing my live, Geraldine. We go back to our rule. Skip 1. So this is a column we skip. And we only need to look at this one column here. So the question is, what times 2 is equal to 8 or less? Wow, math has changed a lot. No, this is actually old math, Nikki. This is really old math. So the question is 2 times 4 is equal to 8. So we have 4 here, and then we take away 8. Make sense? So now our next one, 2 or 6, right? Because I have my last one is here. 6. 6 is bigger. Same thing. Skip 1, eat 1. I skip this column over here. So 2 times what is equal to 6 or less? 2 times 3 is equal to 6. So we take away 6. So this is an assisted way of long division. Yes, thank you. So what is my answer? What does my answer look like? Can we read it? So if we read it, here's my ones, my tens, my hundreds. If I look at it, I have 2, 200, 40, 4, 1, 2, 3, 4, and then 3. 1, 2, 3. So there's my answer. There's my quotient. Yeah. So Nikki, just in case you don't know how to read the abacus, let's do a little review. So what we're going to do is we're going to count. 1, 2, 3, 4. And then after 4, we have 5. The top bead will always be 5. Right, William? Easy. But again, it's a little bit more involved because you need to know how to read the numbers. But this translates very well to like regular math, mainstream math. But we don't talk about this in mainstream math. In mainstream math, the chunks are too big. But in abacus, the chunks are small and manageable. We just use the abacus to help us track it all. So I don't know if Nikki's still around, but we're going to count. So this is 5, 6, 7, 8, 9. So we have 9. How do I know? 5, 6, 7, 8, 9. The top bead always has a value of 5. The bottom bead always has a value of, oh good, the bottom bead always has a value of 1. Does that make sense? So what we're doing is we're trying to read the abacus. After we read the abacus, then we can go into adding and subtraction. But when you came in, we were doing division, and that's kind of like a little bit more intermediate. But the idea is to understand how to read the abacus first. Is that all right? So, oh, here it is. So what's going to happen is, if you notice, this is 9. But then each column has a 9. These are called columns. These columns also help you with place value. So if we look at it, just like how we write, we have our ones, our tens, our hundreds, our thousands, our 10,000. So just as we write, we have our 90. This is a 0. This is a 9. And then we have 190. After that, we have 290. Thank you, Kobe, for the follow. Does that make sense? 300. Why? Because it's 3. 1, 2, 3. It's touching the horizontal bar. The horizontal bar is what tracks our beads. When we get our beads to be tracked, then we know how to read the abacus. Does that make sense? Are we okay with that? So math hasn't changed. It's just a different way of looking at it. The abacus has been around for a lot longer than I've been around. But the abacus has been around ever since we started to barter. After like long time ago, like after learning how to barter and trading, right? We started using pebbles to keep track of numbers and digits. So then after that, abacus was invented. That was like way back in the Mesopotamia. Right? So the difference is, what is the difference? The difference is in new math is actually abacus math. The difference is, in new math, you write it out. In abacus, it's all done for you on the abacus. So, okay. So that's a little bit about that. So then we have our decimal. If we can deem this as our ones place, then the next column over to the right will be our decimal. This would be the tenths and the hundreds. But then, why do we do this one? Well, it doesn't matter which dot, just like a Pokemon. It doesn't matter which Pokemon you use. It doesn't matter which dot you use. It doesn't matter which home you call home. It just matters which one you call home. If I said that this is my ones, then I have all of these to be my decimal. Thank you, Scene. Okay. So this is this is my ones, and then all of this will be my decimal. But if I know my number's going to be big, then I can use this as my decimal, as my ones, and then I have all of these to be my numbers. Does that make sense? So it's different. Is it different for this one? No, it's the same thing. This one just happens to be bigger because size matters. What does that mean? I just have more digits. 13 columns is a lot of digits. Right? 13 columns are a lot of digits. It doesn't matter if you choose this one, this was my home, this is my ones, this is my ones. It doesn't matter. On the 13 one, I like to be in the middle. Right? I like to be in the middle because it's nice to be in the middle. So it actually doesn't matter which dot indicator you choose. You just got to choose something, right? You just got to pick a path and just choose it. Same thing with the dot indicator. Just pick a path, pick a dot. It doesn't matter. And then you'll figure out if you need more digits or not. I mean, there's been times I use this one on a multiplication and I don't have enough beads. So like, okay, you know what? I need to transition to this one. If you're looking for an abacus for yourself, I would recommend doing a 13 column one. Hey, duck. Why? Because you can get to bigger numbers and you can also do multiplication and division easier. It's a little harder to do this one, multiplication and division, on this one because there's not enough columns to keep track of everything. The biggest thing is keeping track of your numbers. The abacus is used to only track your numbers. You're actually the calculator. Like all of this that I write out, this is what we are doing in our heads. Right? This is what all the abacus does, is it just knows to tell you what the numbers are. That's all the abacus is doing. But the thing is with the abacus method, it provides critical thinking. Because we need to understand how to do this. What are we trying to do? Which one is bigger? Which one is smaller? What is the next thing that we're trying to do? So there's rules that we have, just like how we have when we did our adding and subtracting. Thank you so much for the likes. Just like we did adding and subtracting, right? There are rules. We know how to make a 5. We know how to make a 10. How do you mishmash them together? That's the question, right? The idea is how do you fit all together like Play-Doh? You can get a green Play-Doh and a red Play-Doh, and how do you put them together so they can make something? So that's one thing. So this is addition and subtraction. Because we know how to add a 5, we know how to take away the 5. Same thing if we know how to add a 10, we can take away the 10. So we build our concept. We build on top of each other. We don't create a new strategy to figure out what to do. We just, if we know how to add an 8, we know how to take away the 8. Does that make sense? So, and so we were just talking about multiplication, and we talked a little bit about division. What does everybody want to do now? Thank you for the new ways to look at Abacus. Have a good day. Have a good day to you too, William. Thank you so much for joining and asking questions. I do appreciate it. Thank you so much. Yes, I hope to see you again in my next lives. And it's the same thing. I mean, I have books and everything that talks about Abacus, and we have I have workbooks that we do it. So the workbooks right now is geared towards kids, but I am building out a workbook for adults. I just haven't, I just got to sit down and figure that out a little bit. So, anybody have any more questions? Thank you so much for liking the live. Okay, so I only see Go To Finds Scene and William leaving, and then I see Kobe, because Kobe has shared the live. Do you guys have any questions? I mean, we can continue on. Oh, sorry, that was my dog. All right, so we can go back to adding and subtracting. If we're okay with that, we can do that. We can do adding and subtracting, something a little bit more manageable. But that's what Abacus does. Abacus provides manageable chunks, and so we can count it again. What we can do is we can start looking at it and understanding how to read the Abacus. So the first thing we need to do is understand how to read the Abacus. Thank you so much for liking the live. So we have 1, 2, 3, 4, and then after 4, because these beads are touching this horizontal bar, can we do some adding and subtracting with decimals? Yeah, that would be easy. You know why? Because it's just the placement of the columns. Let me show you. Let me show you the number of ways. Okay, so here's a question. 6.84 minus 1.31. This is going to be easy. Why? Because all we got to do is put in 6, 8, and then 4. That's it. Because the Abacus keeps track of our decimals. So what's going to happen is we're going to take it away. Take away 1, take away 3, take away 1. That's it. So my answer is 5.53. I look at my Abacus. 5.53. That's it. Really, what with the decimals just means extra columns, right? So even if we had more, let's do this one. 9.1152 minus 3.4873. Same thing, right? This is my decimal. So let's do it on this one. We could do it on this one. I'm sorry. We could do it on this one. We could do 9.1152. Now, it all depends on what the numbers we're dealing with, right? So we do numbers. We have take away 3, so we take away the 3. Now, this one we need to take away the 4. Do you remember how to take away the 4? There's not enough beads to take away 4 because there's only 1 here. So the next thing is, can we take away the 5? No, we cannot take away the 5. So what's the next one? The next one is how to make a 10. So we have to take away the 5 here. Take away the 10. So minus the 4 is equal to minus the 10 plus the 6. So I minus the 10 and I add the 6. And then we do it again for 8. I can understand the subtraction taking away the beads, but adding doesn't make sense to me with the 5, with greater than 5. Why? Because it's 5 and then 6. So when you put it together like that, or are you talking about the formulas? So those are two different things, right? The formula. Okay, wait. Let me finish this question. So minus the 8 is equal to minus the 10 plus the 2. I watched your stream for the first time the other day, and now my class is doing part on Abacus. That's funny. That's funny. That's exciting. Let me know if you have any questions on it. So we do 8. So take away the 10 plus the 2. and then 7. We're going to take 7. So minus the 7 is equal to minus the 10 plus the 3. So we take away the 10 and we add the 3. And then take away the 3 again, right? Because we got to take away this 3. There's not enough to take away the 3. What do? See how it says minus 7 and then 3? These are pairs. What a great laugh. Yeah, hopefully I didn't blow out your speakers. So minus the 3 is equal to minus the 10 plus the 7. Do you see how they're related? They're related. So we're building and making a deeper connection of our numbers. So we have minus the 10 and then plus the 7. So my answer is 1.6279. So, Emmy, when we talk about the minus, the question is are you talking about when there's more than, when we need to add another 4? The project is on the Chinese abacus, which I didn't realize is different. Yeah, the Chinese abacus is different. Yeah, so let's do a review on the Chinese abacus. So the Chinese abacus it started with the Chinese, it didn't start with the Chinese abacus. The Chinese abacus created it, and then the Japanese made it more efficient. And you know what? Let me know if I am not wrong. If I am wrong. No, I mean in general. I know how addition works. I just can't comprehend it. Oh, interesting. Yeah. Okay, that's really interesting. I wonder if it's I wonder if it's a disc. I'm not here to diagnose, but I wonder if it's a dyscalculia thing. I don't know what it means to be dyscalculia. It could be one of those. But here's a question, Emmy. Did it make sense to do it on the abacus? Because I heard some people that have dyscalculia, they were looking at the abacus and it helped them see the numbers better. So that was a thing. So Paris, just to review about you. You made me fall in love with abacus. Really? Okay. So when you're talking about I don't know if there's a lot of video out there on Chinese abacus. Just so you know, there's 1, 2, 3, 4. I remember I'm just doing a review. So this is 5. And then when we start talking about it, I remember we had to do exchanges, right? So there's a lot of exchanges. This is 5 and then this is 5. And then again, if this is a value of 5, this is also a value of 5. Visual learner helps. Yeah, visual learner, this helps. I think so, Stony. And also those that are visually impaired. Because I'm a math teacher. Oh my. There's also an abacus called the Kramer abacus, and that's for the visually impaired. I'm a math teacher. Promise I don't. Sorry if my grammar is bad. I'm just not sure how to add with the abacus. Oh, okay. I see. How come there's another bead on the top? Oh, because that's the difference, Paris. That's the difference between the Chinese abacus and the Japanese abacus. So the Japanese abacus made it more efficient. So this is the new modern way of doing abacus. Does that make sense? So that's why when you're doing your research, it will talk about time periods. So Chinese abacus started way back. I don't know how long, but it started way back. And then now, recently, the Japanese abacus came about. There's like a whole bunch of abacus competitions, but they're based on Japanese abacus. You still need to know formulas for the Chinese abacus. So like if we did 4, right, and we need to add another 4, we still need to they do function relatively the same, except that the 5, there's more exchanges in the Chinese abacus. So if I do 5, I have to exchange it to make this as 5. So then 6, 7, 8, 9, 10. Because I have 10 here, I either exchange it from this to this, or I exchange this whole thing from here to here. Now the difference is also place value. The reason why is because this doesn't make sense anymore. This is now a 10, whereas if we did this is 10. Now it makes sense because we talk about place value. So you could talk about the pros and cons about Chinese abacus. I hope you get an A. So that's the one thing, is understanding the difference between the two. So, I mean, there's a bunch of videos out there how to count it, but to understand the fundamental and the function of it, it's a little bit different because there's a lot of exchanges that happen. And the Chinese people that do it, they do it really quick, so you can't catch it. But when I take it a little bit slower, you can see that I have to do an exchange. So I imagine the top and the bottom beats. And, it, I don't know. I don't know. I don't know because I don't. It may be, but yeah, I don't know. That's not something I could say because I don't. I don't know. It depends on the. I mean, if I really worked it right. If I did like what 99, 911, and then I add three. I think it's whenever we get to the five. So, or we get to a 10 and then you do an exchange. Eh, maybe that's a valid theory, but it could be that. It could be that. Because even if we had plus the 9, plus 9 is plus the 10 minus 4. Plus the 10 minus the 1. So if we add the 9, it's plus the 10 minus the 1. So it's still 14. Yeah, I guess it's an interesting theory, but I wouldn't know. It's not. I'm not very versed in the Chinese abacus. I just only know as much as when I play around with it and I compare it to the Japanese abacus. I know that they still do formulas because you still need to, like, if you had 4 and you need to add another 4, there's no way to add a 4, but you have to plus the 5, take away the 1. So I think you still need to utilize. Yeah. Yeah, you're welcome. You're welcome. Let me know if you have any questions. I can only imagine. I Yeah, I can only imagine that. I think the theory seems like it's correct, but I don't do a lot of this. But I do know because I was trying to work out, like, is there a way to go without formulas? And there's not a way. So if I did this right, this is 8, and I wanted plus the 9. I plus the 10. I still need to plus the 10, take away the 1. I need to plus the 10. I can't plus the 10 here. I would have to plus the 10 here. So plus the 10 minus the 1. So then my answer is 18. So I think in Chinese abacus, you still need to know your formulas, just like the Japanese abacus. It helps with our overall understanding. Oh, yeah, you're welcome. You're welcome. Yeah. I mean, we can always break it down. Whenever you have any questions, let me know. You know, I'm live quite often. So catch me on a live. Tomorrow, I'm going to be on YouTube live for sure. Scheduled at 9 Pacific Standard Time. If anybody wants to go, I will be on YouTube. But that's tomorrow. Because I have an online class and I make sure I provide service to, because in TikTok I'm kind of like whenever I have time, but this was for my students. So I have some online students that have my and what I do is I'm available for them so they can ask any questions. And it's usually just it's usually the parents. Yeah, I think this might help my new hobby. Yeah. Yeah, I don't know where you would find a Chinese abacus. I'm sure you could find it on Amazon. Maybe on TikTok as well. This one just happens to be given to me from a retired somebody. Somebody retired and just they're not using it anymore. But this one, I have a bunch of colorful ones that I sell on my website, and then this one over here is I got from Daiso. So Daiso is a Japanese like 99-cent store kind of a thing. Is your YouTube the same title as TikTok? No, it's in my bio. You'll see it's Miss Lynette because I was trying to be like Miss Rachel, but I didn't know what I was doing, and it was too late to like exchange it. So, but yeah, but it's in my bio. I believe it's just Miss Lynette, and I just talk about abacus. I don't talk too much about the Chinese abacus. I talk a lot about the Japanese abacus. So yeah. Let me know how the project goes. And I'm not sure how versed your teacher professor is. I'm not too versed. I'm just letting you know. This is just like theories that I have in my head. I don't know the full extent of Chinese abacus, and then again, I don't know too many people that would be able to explain it either. But yeah, like we can talk about, the formulas and stuff, just as I was talking about here, like isolating the variables, substitution, how abacus is the gateway to complex math. Why? Because what we need to do is we need to understand the fundamentals. And if you want, you can use those exact same words. Because what I'm trying to do is I'm trying to popularize abacus. What kind of class project is this? I'm so curious, Paris. What sort of, why would you have a project to do this? Is this a math class? We just started learning about ancient Chinese mathematics, and this is the topic I decided to do. Oh, ha ha ha! That's funny. The history of mathematics. That's very interesting. That's very interesting. Um, yeah, we now have different variations of abacus. So if you take a look, if you have time, yeah, we could do multiplication decimals. Before I forget, so there are other types of abacus. Sorry, I need to. There we are. There are different types of abacus. There is a 10-bead abacus. I don't know if you know this, but I will do multiplication with division. I'm becoming a math teacher. That's why. Oh, interesting. For what grade? Do you know? I don't know. How would multiplication division work? And would fractions work? Fractions work because fractions is just another way of looking at division. So yeah, fractions work. It's just if you have a mixed number, you still have to make it bigger. Middle to high school. That's interesting. That's really interesting. It'd be interesting to see how strong the kids are with their number. Just a class to that requires to take. Yeah, that's really interesting. That's right. So before I forget, there's Kramer abacus. This is an abacus that's used for visually impaired. We have the rec and rec that's very popular in math now. It's a rec can rec. Rec and rec. I think that's how you spell it. A rec and rec. This is a rec and rec is a Dutch abacus, and what it is it's 5 beads that are red. 1, 2, 3, 4, 5, and then there's white beads. That another set of white beads, but they're all it's a division of 5, and it's still on an abacus, right? So it's still in a frame like this. Emmy, I'm a middle school math teacher. I know my kids struggle with the concept of fractions as division. Oh yeah, I mean that's as far as I go. I mean division is really just fractions. That's as far as I can say. But yeah, I can do division on the abacus. We did that here. And we can do multiplication. We can do decimals as well. Decimals is the same. It's just with more digits, that's all. And it just depends on where it is. So, yeah, good luck with that one. Yeah, I don't know. I don't know how else to... Because I don't teach math. I teach abacus. So when Scene was asking me about, like, multiplication table, the only thing I can say would be to use it as the abacus. Because that's all I know. The abacus that I know is actually just a side business. My dad wanted to build a business, and he forced my brother and I to learn. And what happened was we learned and he didn't. So I was like, okay, well, whatever. And we've been teaching abacus for 20 plus years. I have a bunch of students that has gone through the system, that has gone through the curriculum. Some of them come back, but a lot of them are young and they don't remember. But those that do graduate, then when they come back, they do appreciate the idea, the confidence that the abacus is given to them. But other than that, like making abacus more mainstream is now my goal. My goal is to try to make abacus more mainstream, to try to bring in it at as a younger age. So that's where like because the difference is in elementary school, which is interesting, they bring in a bunch of math manipulatives, but nobody talks about the actual abacus himself. There's one that's a 10 bead, but the 10 bead doesn't do place value. The abacus, this abacus, even the Chinese abacus, we can talk about place values. So Paris, you can talk about that, right? You can talk about the different manipulatives. I don't know how you're going to fit it in. Anyways. So there's a rec and rec, there's a Kramer, there's another one called the Right Start abacus. And it's the same thing. It's another abacus that's a 10 bead, but their colors is yellow and blue. Yeah. Japanese abacus is base 16. Base 16 means you only go to 16 numbers. So no. Chinese abacus is still a 10 base because it still uses it as the decimals. So the columns are still 10 based because there's exchanges that happen when And that was the thing. Like, somebody asked me if the Japanese abacus is a 5 base, and I was looking it up. I mean, those are really big words for me. Like, I don't understand the concept. But when I was looking at it, what a 5 base means is you only use the 5 numbers. 16 base is not a, no, this is still decimal based. This is still 10 based, because we still do 10. This is still 10. This is 20. This is 30, 40, 50. So this is still 10 based. There is 16 is this, right? I don't know how this can be other than 16 base. We don't have 16. This, if you put it together, is 15. So, Jason, I'm not sure if that's the correct terminology of base 16. Unless it's different, unless I understood it differently, I don't think that that's the correct terminology. I think like hexadecimal is 16 base because we have 0 to 9 and then A, B, C, D. So like when we do colors, right? Colors is 16, it's a hexadecimal. 16 hexadecimal, hexa whatever, right? Because we do 0 to 9, right? And then we do A, B, C, D, E, F. So the hexadecimal, when we do colors, is your base 16. Abacus is not a 16. Huh? Yeah, there you go. Thank you, Jason. Thank you for the comment. So yes, abacus is not a base 16 because there's no alphabets here. Hexadecimal. When we start talking about colors, when we start talking about colors in web developing, right? In our websites, we have colors, we have hexadecimals. Hexadecimal is where that is, because it's 0 to 9, and then there's the alphabets. The top beat is 5. The 2 but yes, so we have 2, 1, 2. That's 5. That's still, and the plus the 5 bit can go up to 8. Then it rolls over. No, it kind of does. It kind of does, but it doesn't really, because what it is it's more of an exchange. It's not. I don't think it's used that way. So what I think is it's more like if you get 5, you'd exchange it for 5. If you do 10, it exchanges to 10. I don't think it does a rollover like the abacus on the Japanese. Because even if we did this 5, 6, 7, 8, 9. So we have 9. When we do 9, when we have 9, we want to do 10. Like 9 plus 9. We still need to do plus the 10 minus the 1. I understand this is being used counter how it is intended to be used. Yeah, I'm not sure about the rolling over though. Even at 16, even if we did this to be 15, this is not 16. This is still 10. You know what I mean? So the rolling over, that doesn't make sense to me. That's interesting, but it doesn't make sense because this is what the rollover is, right? So if we have white is F, 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 F. If we change this to 0, 0, 0, 0, I think this is green or whatever. Can you show some simple arithmetic on it? On the Chinese abacus or the Japanese abacus? Chinese abacus. Okay. This will be a little bit because I'm not very fluent in it. But we could do, okay. Somebody wanted decimals. Emmy, did you want decimals as well? Division? Oh no, Scene wanted decimals with the multiplication. Okay, Scene. If you can hold on for a little bit, we'll do multiplication with decimals. I just need to write that down. X point X times that by X point X. Okay, so that's one. Scene. Okay, so we could do this one. We do 300. Let's do this one. 200. Simple. Let's do simple. 15 plus 3, I guess would be simple. I mean, so we have 15. Well, we have 15 and we just add 3. That's what we're doing. That's what we do. We just add the 3. So it's similar. So even if we did, let me go back. So even if we did this one, right? Even if we did the 9. Even if we did 9, that's not 9. This is 9. So this is 9, right? And we want to add the 8. When we add the 8, it's still the same thing. We still need to plus the 10 minus the 2. So we still plus the 10 and then take away the 2. So our answer is 19. So the concepts are still the same. See, that's still the same. So if we did 12 plus 9 plus the 9, there's not enough beads to plus the 9. Even if we add these two, there's not enough to plus the 9, right? Because this is 5, 6, 7, 8. This is still 8. You could do this plus 9, but you still have to take away 1. So you could do this. So there might be that, right? Because I'm plussing the 9 means I take away the 1, but I plus the 10. So my answer is what? We would have to exchange it. This is 10, so I do that. So it'd be 21. So that's the thing. So if I did this, 12 plus 9, there's two ways to do it. I can either plus the 10 minus the 1, or I plus the 10 minus the 1, right? We could do that. But if we do this, then it gets exchanged. I would end it here. Does that make sense? So no matter what, you could use this, but I would end it here. Then multiplication is just repeated addition, correct? Yes, exactly. Multiplication is just fast addition, right? Just like, yeah. But so I would still exchange it to here. So then you could see the number that's 21. I don't think they would see this and say 21. I think they still exchange it to get to the final product as we write. So, yeah. Hey, Luna. Welcome back. Okay. Do we have another question, Paris? We can do minus. It's the same thing. 17 division. We can do on the Chinese abacus or the Japanese abacus. It would still be the same, but the difference is now we have to figure out where our place value is. So it's still the same. It's still this. I still believe it's the same. So if I can review, if I can use the ones that we did before, it would be helpful. Oh, but the thing is my abacus doesn't have a dot indicator. Ooh, the difference between the Chinese abacus. Yeah. What is the difference between the Chinese abacus and the Japanese? The Chinese abacus has more beads. That's all. That's the difference. So if you have a Chinese abacus, you can just ignore the first two. The other problem is I don't have a dot indicator, so I would have to memorize where I started. So if I start here, but then I won't. Okay, anyways, so if I start here, let's say I do 4, 8. That's wrong. 6. Right? I'm going to divide 2. So I know bigger, so I go here, I add 2, I take away this. My issue is because I don't have a dot indicator, I don't know where I'm starting. I don't know. I would have to play around with because on the Japanese abacus we count 1, 2, 3, 2, 1, 2. So I know I'm going to be here, but on the Chinese one it's a little bit obscure, if that makes sense. So I know I'm going to put my 2 here, so I take away 4. Yeah, that's really interesting. So if we continue, I know that this is 8. I'm still going to skip the same question. It's still the same, but I don't know if this is going to be 243 or if it's going to be, 24.3. I don't know the difference. So this is 8, so I do 4, and I take away 8. And then 6, right? 6 is 3. So that's the question is, because I don't have an indicator, I wouldn't know where my place value is. I know this is 2, 4, 3, but I don't know where my decimals are, if that makes sense. That's the interesting thing about it. I would assume that that's what they do with the Chinese abacus. But I don't know if they do multiplication and division on the Chinese abacus. You can, but I don't know if they do. Because a lot of it is just counting, right? Like adding and subtracting like an accountant. I don't know how many accountants go into multiplication, right? When we talk about business and money, we don't do too much multiplication. We only just recently started buying in bulk, if that makes sense, right? So understanding the concept, understanding the culture of when it started. When did we ever start buying in bulk is only when we start to have factories, right? When we're able to start replicating more things. So it all talks about the timeline on how things are working. So I'm not sure if they did division and subtraction on the abacus because I don't know if that was needed back in the day. That's my thought. That's a theory. Yeah. If somebody is more fluent in Chinese abacus, I would definitely ask them, like, do you do multiplication on the Chinese abacus? You can. I just showed you can, but I don't know when and why they would, depending on when they did it. Does that make sense? So like even when we balance a checkbook, like I remember there was a Chinese abacus in the bank. How often do we do times and division in the bank? We don't do too many. It's always just adding and subtracting. So adding and subtracting is very good. It's just adding. Yeah, I know multiplication is just adding, but understanding where it came from, right? So like back in the day, how many times do they needed to have 17 apples for 4 people? You know what I mean? Like how often would that happen? How often would it happen to be like, I'm having a party? How many times do we have parties? Like back in the day, right? When we were bartering, we were always talking about ourselves. So I think it's a cultural thing. Like time wise, only now, right? We have Costco, we have factories. We didn't start having factories until when? The 1920s, the 1930s. The abacus has been around before the factories. So that's my theory behind it. We can talk more. I don't know too much about the history, like the logistics of that. But if I started thinking about it, like how often is there a factory? There isn't a factory back in the day when we started bartering in businesses. So that's what I wonder. You could do it. It is possible, but I don't know if there was a need to. That's the question. All right. So now you need to make a Kaylee. That's too much research. That's too much research. What I would like to do one day is figure out how to make a research paper on why abacus is beneficial for students, but I haven't figured out like the formatting of that. There are so many of them too. There are so many of them. So many of what? Abacus history books? Yeah. I don't know. That would be interesting. Okay. So, yeah, I mean, in comparison, there are other abacus. Yeah, there are different types of abacus, yes. There's also a Roman abacus, and it's the same concept. It's just in a plate form with beads on it. There's other ones, but again, I think it's still a 10 bead. I think it's still 10 beads. The concept is still the same. The word itself, abacus, just means moving of the beads. That's all that really means. We're just moving beads. And I'm always playing around with Mike. Okay, so I don't know if Scene is still here, but I did promise to do multiplication with decimal. And all I gotta do is this. Okay, so the first thing we're gonna do is now we gotta figure out our decimal. So we have 2.99 times that by, let's do 2.48. The concept is still the same, but But we're only going to count the number in the front of the decimal. It gets a little wonky when it goes behind the decimal. So here is 2. So we're adding a 2. So our place value will be 2. We know this, 1, 2, because it's 1 here and 1 here. So that's what we're adding is whatever's up here. It's still the same thing. 2 times 2 is 4. 4 is a single digit. I go back one column, I add the 4. Then 2 times 9 is 18, right? 2 times 9 is 18. So I add the 4, I add the 1 plus the 5 minus the 4, and then add 8. And then I do it again. 2 times 9 is 18. Add the 1, add the 8. Hopefully you guys can see this, because I'm always playing around. So now, I've already done with this. I started here, so I go back one column, because I have one digit less. It gets a little confusing now, because now we're talking about the minus, but what we're doing is, it's 0 and then 1. I guess this is where we start going in negatives. 4, I'm going to change it to a different color. 4 times 2 So I'm here. 4 times 2 is 8. 8 is a single digit, so I go back one column and I add the 8. Why? Because 8 is a single digit, so I need to go back one column and I need to add the 8. To add the 8, we know to plus the 10 minus the 1. Plus the 2. 8 is equal to plus the 10 minus 2. Oh, you can't see that. I'm trying to... There we go. Maybe that's better. So, plus the 10 minus the 2. Plus the 10, take away the 2. What did we just do? 4 times this. So now we got to do 4 times 9. 4 times 9 is 36. So I add the 3, and then I add 6. I add 3. I add 3. Cannot add 3. Plus the 3 is equal to plus the 10 minus 7. Plus the 10 minus 7, and then plus 6. Again, plus 6 is plus the 10 minus 4. Plus the 10, take away 4, not enough. Minus 4 is equal to minus 5 plus 1. So minus the 5 plus the 1. And then plus the... We're done, right? And then we do it again. So we're here, so we got to do it again. 4 times 9 is equal to 36. Plus the 3 is plus the 5 minus the 2, and then plus the 6. I'm hoping that this is right. So we're done with this one. Now we got to go to the 8. But instead of being here, we go now to this one. So the question is 8 times 2. 8 times 2 is 16. I add 1, I add 6. I add 1, and then I add the 6. Plus the 6 is plus the 10 minus the 4. So I plus the 10 and I take away the 4. Minus the 4 is minus the 1, plus the 1 minus the 5. And then 8 times 9. 8 times 9 is 72. Add 7, add 2, add the 7. Not enough, so I need to plus the 10 minus the 3. Plus the 10 minus the 3 plus the 2. And then I do it again because I have this one here. Uh-oh. Plus the 7 plus the 2 plus the 7. Plus the 7 is plus the 10 minus the 3 and then plus the 2. Hopefully that was okay. Oh, Cena's still here. So my answer is, this is what my answer is. 7, I'm hoping it's right. Because I know I move my abacus a lot, and I hope it doesn't, I hope that the answer is okay. So it's 7 point, because I know I'm here now, 0.415. Oh, sorry. There we go. So just as we write it, 7.4152. But yeah, I wonder if that's the correct answer because I've been moving my abacus a lot to show you how I did. Is it complicated? No, it's not complicated. It's only because these are formulas that you need to know. No. These are the formulas you need to know, and that's the difference, right? I've been doing abacus for 20 plus years. I checked the calculator. Oh yeah, is it correct? But don't forget, I mean, I didn't take it slow because there's a lot of numbers. Usually the numbers I give you guys is a lot smaller, but I just wanted to show that it is possible. And it is possible. It's just keeping track of the numbers is one thing. And so it's different to be presenting and talking about this. I should check the calculator too, just in case. Okay, so 2.99 times that by 2.48. 7. Okay, good. It is correct. But that's how we do it. That's how we do it. But the thing is you have to keep track of everything. And then, again, if you notice, these are all of the formulas that we just need to memorize. We need to memorize our 5 formula and our 10 formula. That's it. That's it. Everything's the same. Everything's the same. So, yeah. You can do up to decimals. Yeah. Fractions, is the same thing. It's just a concept. I mean, how to teach kids fraction is another story, right? How to show, like me showing you, but then trying to figure out like how to teach it to kids is another story. Usually I have kids that starts Abacus with me, so getting them to understand division is very easy, right? I just show them the basics and then grow the question. Just like with multiplication, I start with the easy and then I grow the multiplication to do other things. Just like addition and subtraction, we start from small, and then as we grow and get bigger, there's more numbers to start figuring out what to do things. So, but yeah, I mean, yeah. Anybody have any questions? Ooh, this was a good one. This was a good one, especially when you talk about the Chinese abacus. But no, going back, I don't know if he's still here, but I don't believe that the Chinese abacus is 16 base, because it talks about the values of self. So I don't believe that that's a proper, I don't know. I mean, if somebody is more scientific than I am, and they can prove me wrong, then that's fine. General mental math tips. A lot of it is just practicing. So like, a lot of it is just practicing. You could find a lot of strategies. Like there's the Japanese lattice thing. There's a bunch of that. My mental math comes from Abacus, and it's only because I've been dealing with Abacus for 20 plus years. General things, honestly, I wouldn't push to go to mental math quickly. I would stay with the abacus as long as possible, just because it's nice to see the numbers. It's nice to be able to get confirmation that what you're doing in your mind is what you're doing in your brain. So like even still, like my kid, he's in 6th grade, and if he ever has a problem with his arithmetic, I say, you know what, break out the abacus. Because the abacus is just so helpful to be able to see it, and it's not in abstract form. Because these numbers are still abstract if you think about it. Even this as a picture, it's still difficult. Hey, Audrey! Scene, if you're interested in algebra, Audrey would be the one that I would talk to. Maybe she can talk to you about some mental math stuff, because she does algebra. For me, I just do arithmetic. Yeah, like arithmetic is just adding, subtraction, multiplication, division. And the biggest thing is, honestly, the biggest thing to really go mental math, I would say continue to play around with the abacus. Hey, Pog Champion, thanks for the follow. I was just talking about you. Really? That's so funny. I've been studying for the MCAT and we don't get a calculator. You could, I think you can bring the abacus because it's a calculator, but it is not electronic. There has been a student that went to UC Berkeley, and he was one of my students, and the teacher said, professor said the same thing, no calculators, and he's like, fantastic, is it okay to bring my abacus? And he's like, yeah, you can bring your abacus. So if you can get your abacus solid, then it'd be gold. I truly think it would be fine for you to bring it, but you can ask. I know there was another person to ask if you can bring an abacus into it, and I don't see why you don't, because you're still, honestly, I only sell this one, and this is not enough for you. Why? Because you need the one with more digits. You know what? You can DM me, and I can give you the link. I can give you the links that I have on Amazon. You can use it. Oh yeah. Oh, Audrey, really? Okay. That's interesting, and it's true, right? Because it's not electronic. You're still doing the calculations in your head. All of this stuff is what you do in your head. You're just moving the beads. The beads are just helping you track the numbers. So that's really interesting. I know. With my kids, primary, like kindergarten teachers, they were okay, but they also knew me, and it was just another math manipulative for the kids. But my kids were too young to even understand what they were trying to do. So, good luck, Scene, for your MCAT. I know that was a bear. I couldn't get past it. I'm not smart enough to. I'm not smart enough for standardized tests. I wish I could, but I couldn't. I couldn't get past this, like SATs and ACTs and all that standardized tests. I couldn't do it. I couldn't do it because I don't know. It's probably because I don't know it well enough. But good luck to you, Scene. Good luck. Yeah, and ask. But yeah, give me a DM and I'll give you one. I would probably recommend, honestly, depending on how big the questions are, I would probably recommend a 23 column one or even a 21 column one. Hopefully that would be within your budget. I can give you links to those, but I don't sell these ones. I only sell the small ones because I was thinking that my students would have been young. I didn't think they'd be like old and adults. So, hey, Nickname, you're back. Welcome back, Nickname. So, but yeah, today's Wednesday. Woo! What a trip. All right. So if anybody has any questions, let me know. Yeah, it was funny. It was really interesting. Professor TK came on board yesterday, and she was just kind of hanging out. And I think I've impressed her that she that I saw her this morning, and she was doing chemistry because she does chemistry, and it's just really interesting to see like other teachers, other professors, other people. Yeah, right. Like she's really cool, and yeah, she was talking about me. I was like, oh, okay, thanks. And it was interesting. It was just interesting. But I don't know if the people that are here. Oh yeah. So, see, if you want somebody in chemistry, because you do chemistry, I know. Professor TK does chemistry. I don't know if you know TK, Professor TK. Yeah, the MCATs. It's been a while since I've seen the MCATs. Anyways, hey, Mama Bear. Okay, anybody have any questions? If not, I do plan to sign off. I've been around. Good to know, but thanks for your help. Okay, yeah, gotta go. Okay, yeah, gotta go, but thank you for your help. Yeah, not a problem. Yeah, if you need algebra or if you need somebody in chemistry, let me know. I have somebody that I know. Good luck. Luna, do you have any questions? Views tanking, sales stalled? No. Anybody have any questions? Thank you so much for liking the live. Yeah. Cool. All right. If nobody else if nobody else has any other questions, I am gonna sign off. I'm gonna kind of regroup a little bit, and I gotta work on my book, right, Kaylee? Whew. I gotta work on my book, but I finally got some stuff done, so I'm in good. I awarded myself with that live. All right. So if nobody else has any questions, I will sign off. Thank you again, everybody, for joining, and I will see you in my next live. Toodaloo, kangaroo.